Hi everyone, a good morning to all. Today we are going to discuss question number 55, that is relation between apparent depth and real depth. To understand this, the very first thing what we have to understand is what is the difference between rarer and denser medium. So when we compare any two media, then only we can say one is rarer and denser. So one refractive index is greater than another refractive index, and the one with greater refractive index is called denser medium, and the one with lesser refractive index is called rarer medium. So whenever there is an interface, light will enter from either rarer to denser or denser to rarer. So light refraction takes place whenever there is an interface. That means whenever light enters from rarer to denser or denser to rarer. And air medium is the only one medium which we always consider as rarer medium because its refractive index is 1, and it's because the speed of light in air medium approximately we equate it to c, that is the speed of uh, light in vacuum. But remaining in every medium, the speed is lesser, where the speed of light in any medium is c by mu. Mu is refractive index, and refractive index is always greater than 1. Now the next thing what we have to understand after denser and rarer medium is what is actually refraction. See here, when there is a interface, when there is an interface, and when light try to enter from denser to rarer or rarer to denser, like suppose you consider this is incident light. Now this is the point of incidence and you take the perpendicular, that is called normal. Now this is angle of incidence. Now this is the actual path. Then if it deviates towards the normal, this is now refracted one, at an angle r with the incident one, this is called refraction. Or else when light is entering, so now this medium to opposite. Now this is our angle of incidence and this is the actual path, and now the light is bending away from the normal. So then we consider that this is rarer medium, this is denser medium. So when light trying to enter from rarer to denser, it will bend towards the medium, towards the normal. When it try to enter from denser to rarer, then it will deviate away from the normal. This is what the definition of refraction of light at plane surface. Refraction nothing but bending of light, and this bending of light happens when it enters from one medium to another medium, and it is two types, rarer to denser or denser to rarer. Now the next thing is what is the deviation produced due to refraction. See here, as we discussed, when light is suppose entering from rarer to denser, so this is the actual path. Now this is bending like this. Now this is R, this is I. Then in that case, this total angle is also I, angle of incidence. Now this is deviation. Now the deviation is I minus R. Same way, when light is trying to enter from denser to rarer, see here, this is incident ray. This is same path. This is angle of incidence. Now it will bend away from the normal. Now this will become refraction angle, and this is the deviation, that is R minus I. Rarer to denser means I minus R. Denser to rarer means R minus I. So these things also useful in solving numericals. Now one more thing is what are the laws of reflection. When you consider light is entering from one medium, that we will call it as like incident medium. Let's take the refractive index is mu1 and it is entering into another medium, any denser or rarer, whatever it is, mu2, then this is our angle of refraction. Then sin I by sin R, sin of angle of incidence, that is in incident medium, equal to refractive index of the second medium, refracted medium by incident medium. And of course, same like reflection, all the three, incident, normal and refracted light, all the three must lie in same plane. So these are the conditions you need to remember. Now what is the relation between real and apparent depth and their speed in case of object is in rarer and denser medium? See here, just try to consider in this way. Now this is one rarer medium and this is one denser medium. Rarer usually we will consider air, but let it be, we don't know, mu1 and this is mu2. Now one object is here, so it is at a real depth dr. It is at a real depth dr. Let's take like x. This value is as x or y, anything. Now one object is observing from rarer medium, it is at a distance x. Now this is observer and this is object. And when we observe from the rarer medium, then due to refraction, see one ray will go like this, straight. See, according to this formula, when I equal to 0, R is also 0. So same way, when there is a normal incidence, that only we call it as normal incidence. So in case of normal incidence, I and R both are 0. But when it go like this, it is entering from denser to rarer, so it will try to bend away from it. Now this is one refracted ray, this is another refracted ray. The intersection is called the image position. Intersection of reflected rays or intersection of refracted rays is nothing but image. So it was at this depth, but it is appearing only at this depth. This depth is called apparent depth, this one. Now if you look at the diagram, apparent is lesser. And here mu2 is greater than mu1 and dr is greater than d apparent. So the relation we will make it as d real by d apparent equal to mu2 by mu1. Mu2 means that is objects and mu1 means that is observers. This is generalized formula. Now similar way, now you consider, see object is in rarer medium now. Here object is there. Now at a distance x. Now here we are observing from somewhere at a distance y. So this is observer. Now one reflection will take place like this. Now another one is like this. But here it is entering from rarer to denser, mu1 to mu2. So here also same mu2 greater than mu1. Now the ray refracts away from, towards the normal, so that the position will shift like this. So the intersection point will come here. Now this is the apparent height. So this is real, this is apparent. So that let's take, this is d apparent. Now this, d real. Now this will become d apparent. Now here d apparent is more now. First case d real was more. So that now in this case when you make the formula d real by d apparent. Now d real is lesser. So that will become mu1 by mu2. First case mu2 by mu1. But mu1 means it is object medium. Mu is object medium only. Here object is in denser medium, that's why mu2 is object. Here object is in rarer medium, so mu1 is object by observer is in mu2. So again the common formula same. D real by D apparent is mu object by mu observer. But if you remember in mu1, mu2 way, then you may get confused. That's why try to remember like mu object and mu observer. Now, if rarer medium is 1, that means air medium, then in first case, that is when object is in first case denser, then the D apparent equal to D real by mu, that is just like Y by mu. Y is real. Now the distance between them was x plus y. Now it will become x plus y by x. Now distance of object with respect to observer, let's take something s, that will become now x plus y by mu. Now if they move each other, then the speed relation you can take it as ds by dt equal to dx by dt plus 1 by mu dy by dt, where s is the appearing velocity of object with respect to observer. Dx by dt is velocity of observer with respect to water surface. Dy by dt is velocity of object with respect to water surface. Dx by dt is velocity of observer. Dy by dt is actual velocity of object. So same way, when you consider when object is in rarer medium now, that means now the apparent distance is mu times, because mu1 I have taken 1 and mu2 you take it as mu, so that it will become mu into d real or mu into x, because x was the real distance. Now the apparent will become mu times increased. Now distance of object with respect to observer will become now s equal to y plus mu x. Now speed, if you want to find, then ds by dt equal to dy by dt plus mu into dx by dt. But here dx by dt is actual speed of object, dy by dt is actual speed of observer, and ds by dt is speed of object with respect to observer. So they will ask like fish and bird case, like when fish is inside, bird is outside, if they are moving towards or away, then you have to consider these formulas. So what is the apparent velocity of bird with respect to fish or fish with respect to bird? So if they said fish velocity with respect to bird means now bird is observer, fish is object. Now bird velocity with respect to fish means fish is observer, bird is object. That means the object is in rarer medium. So that way you need to connect and you need to compare and you need to solve the questions. Now based on the same thing whatever we have discussed, let's see few questions. Now the very first question is, Find the speed of light of wavelength. So wavelength they are given 780 nanometer. In a medium of refractive index given as 1.55. So now wavelength in medium is lambda by mu. Then, so what is the wavelength of this light in given medium? So lambda by mu. Lambda is given, mu is given. Then you will get the wavelength in medium. Now, speed of light they are asking. Speed of light in a medium is c by mu. C is speed of light in vacuum. So where c is 3 into 10 power 8 by mu is 1.55. So if you do the simple calculation based on the speed of light or refractive index, you can solve such questions. So sometimes they can ask based on the question of simple formulas. Refractive index, speed of light in medium, wavelength of light in medium, and relative refractive index of one medium with respect to other. With respect to other means you have to take like mu1 by mu2, 1 with respect to 2, or 2 with respect to 1, mu2 by mu1, like that. And always remember, refractive index of glass is 3 by 2, refractive index of water is 4 by 3. Now, a ray of light falls on a glass plate of refractive index mu 1.5. What is the angle of incidence of the ray? If the angle between the reflected and refracted rays is 90 degrees. See here, there is a glass plate. Now the light is coming and falling on it. Let's take, this is the normal at the point of incidence. Now this is angle of incidence. This is actual path. Now this is reflected light. Then this should become I. Now, what is the angle of incidence if the angle between reflected and refracted rays is 90 degrees? Now mu is 1.5. That means this is rarer, this is denser, because this refractive index is 1.5. Now it will bend towards such that these two angles, the angle between these two rays is 90, they are telling. Now this is angle of refraction. So if you observe I plus 90 plus R, I plus 90 plus R should be equal to 180 degrees. Then I plus R equal to 180 minus 90, 90. Then R equal to 90 minus I. If you apply Snell's law, sin I by sin R equal to mu2 by mu1, where sin I by sin R is 90 minus I, mu2 is 1.5 or 3 by 2 by mu1 is 1 equal to 3 by 2. Sin 90 minus I is cos I. Sin I by cos I is tan I. So tan I equal to 3 by 2. So I equal to tan inverse 3 by 2. So this way you can apply Snell's law. This way you can understand refraction at plane surface and you can solve the question. But whenever you are solving the questions, whether in case of reflection or refraction, later in case of lens or prism, see the mathematics, simple geometry, angle, sine, cos always plays a critical role in solving numericals. So please try to have clear idea about all those things. Now the next question is, a printed page is kept pressed by a glass cube of edge 9 centimeter. By what amount will the printed letters appear to be shifted when viewed from the top? See, there is a glass cube and here letters are there. Now the mu is 1.5. Now when you are viewing from top, that means you are in rarer medium. So it will shift to somewhere. So the shift formula, when you want shift equal to, what is the shift formula? Real minus upper end depth. That means x minus x by mu. So x into 1 minus 1 by mu. Here x is nothing but thickness. So that is t into 1 minus 1 by mu. So that here what it will become is, the x value we have to find. So x is t. T is thickness. So edge is 9 centimeter. So thickness is 9 centimeter given and mu is given. So that x equal to shift equal to t into 1 minus 1 by mu. So all the values given, just try to solve it. But one more thing I would like to tell you here, just after explaining this question, I will tell you. See here, a fish is in aquarium approaches the left wall at a rate of 3 meter per second and observes a fly approaching it at 8 meter per second. Now this is object. First thing you have to decide. Because fish is our observer. Now the observer is in denser medium. The observer is in denser medium means the relation we have taken that S equal to y plus mu x implies ds by dt equal to dy by dt plus mu dx by dt, where ds by dt is observed velocity r, means velocity of object with respect to observe, apparent velocity. Now here a fish is in aquarium approaches the left wall at a rate. That means dy by dt they have given as 3 meter per second and dx by dt they have given as 8 meter per second. Now refractive index they have given as 4 by 3. Then actual velocity of wait. And observes a fly approaching it at 8 meter per second. That means apparent velocity they have given, that is ds by dt, that they have given as 8, and they are asking the actual velocity of fly, that is 3 meter per second is velocity of the fish. So this is dy by dt and this is 3 meter per second. Then we need to find the actual velocity of the fly. Fly is nothing but object. So object means dx by dt is how much? So if you substitute in this formula, 8 equal to 3 plus 4 by 3 times dx by dt. So then you will get the answer. That is dx by dt equal to 8 minus 3, 5. 5 3 is a 15 by 4. Now, bird fish case I said. Consider the situation as shown in the diagram. Find the distance between the sparrow and fish as seen by sparrow and fish. So they are asking different. When they asked sparrow, observed by sparrow means now this is object, fish is object. So observed by sparrow. That means object in denser medium. Because now object is fish. Then the apparent distance will become h plus d by mu. So all the values they have given. Just t, h and all. Now similarly, observed by fish. Now who is object? Sparrow. Now object is in rarer medium. When object is in rarer medium, now the apparent distance is d plus mu times the real distance. So this way, if you understand those questions, those situations, then it will become easy. And one more thing, as I said, I'll explain you. Just remember, like a note. Sometimes they will give the questions like multiple media, one above the other, like this. So in case of single media of thickness t, when there is a object is placed, then the apparent depth is t by mu and shift is t into 1 minus 1 by mu. Now in case of multiple media of t1 mu 1, t2 mu 2, t3 mu 3, so on, apparent depth equal to t1 by mu 1 plus t2 by mu 2 plus so on, and shift equal to t1 into 1 minus 1 by mu 1 plus t2 into 1 minus 1 by mu 2 plus t3 into 1 minus 1 by mu 3 plus so on. So this is one medium. Here multiple media, one over the other. Such kind of questions also will come. Just you need to add all the apparent distances or all the shifts produced by individual media. This is what all about the apparent and real depth and what kind of questions will come. Similar questions I have given as an assignment. So like here see the apparent distance and apparent shift due to multiple media, and there are few questions based on the same refraction, but very less questions are there. But just try to understand and try to solve it. So thank you all of you. Thank you so much. We'll continue with the next question in the next session.